Hello everyone. Today we are learning about energy conversion. So very importantly, you need to understand the first key doctrine or key concept in energy conversion. Your teacher will definitely teach you this concept. Energy cannot be created or destroyed, but can be converted from one form to another. So you must memorize this. Okay. Energy cannot be created or destroyed, but can be converted from one form to another. So we will learn different forms of energy today. And quite interestingly, do you know what is the first energy created by God? First sort of energy created by God in the universe. So if you refer to the Bible, there's this verse, Genesis chapter 1, verse 3. And God said, "Let there be light." And there was light. So from here, we can deduce that the first sort of energy created in the whole universe is light energy. So today we'll learn about kinetic energy, potential energy, light energy, electrical energy, sound energy, and heat energy. So first of all, one typical example, you have played with balloon before, right? So I try to make this balloon more interesting by adding the eyes here and the nose and the mouth. So if you inflate this balloon, it stores potential energy. Why? Because the balloon, the properties is elastic. So if you inflate the balloon, the energy stored inside is elastic potential energy. And once you release, right, the air from the inflated balloon will escape and the balloon will move forward. Okay. So this is what will happen. The balloon will move forward, right? Because the air here will be expelled here. So the potential energy is converted to kinetic energy plus sound energy. So you add in this in the worksheet. If it's not added, sound energy. Yeah, because as the air is being let off, you can see it, correct? It fly around. Okay. There's sound energy produced by a student here. Hopefully it can't get into the mic. Okay, so what is kinetic energy? Yeah? Kinetic energy is energy of movement or motion. So please fill in the blank. So I use these three examples to show you. Why I use these three examples, there's a reason for it. Because it can occur in a solid. Car is a solid. Wind is a gas. And water is liquid. So kinetic energy can exist in three different types of matter: solid, gas, liquid. So have you filled in the blank already? This part. You don't have the notes, is it? You have this? Okay, fill in the blank. So next, a stationary object does not have any kinetic energy because it doesn't move. Okay, stationary object, it doesn't move. And then when it slows down, the kinetic energy decreases. Okay, decreases. Can see? Okay, kinetic energy does not vanish into thin air, but is converted to other forms, such as heat energy or sound energy. So, for example, a car that stops on the road, right? So, as the driver applies the brake, right, the kinetic energy of the car is converted to heat energy because the brake pads sandwich against the disc brake. So, this will produce heat energy. And sometimes, if you brake too hard, screeching sound, right, sound energy is heard. Okay, next thing, interesting. What does kinetic energy depends on? It depends on these two factors, mass and speed. Okay, mass you learn in primary 4, right? It's the amount of matter in an object. So if you in this blank, the greater the mass, the higher is kinetic energy. And also the higher the speed, the higher is kinetic energy. So kinetic energy is measured in this formula. You can copy this. I'll pause for a while. Okay, as I mentioned, this formula is not required for PSLE. Okay, you will not be tested, but it is definitely good to know how mass and speed affect kinetic energy of objects. Okay, now we want to do some investigation. Okay, there are two balls, right, moving at two different speeds. One at 3 meters per second, ball A, ball B at 6 meters per second. So applying the formula, half times mass times V square, you will calculate ball A and ball B. So you can copy down this working which I have done earlier. And then you will discover that if you increase the speed by 2 times, from 3 to 6, right? 2 times, right? Double, right? What happens to the kinetic energy? If from 9 joules to 36, increased by 4 times. Okay, so you just plug in the values inside. Half times mass, right? In mathematics, you learn in P5 and P6. It is called cross multiplication, right? So they cancel out. Correct? Cross multiplication, right? Yeah, and then similarly here. So what is square? Square means 3 times 3, 3 square. So you get 9. Okay, unit for energy is called joules. Joules is a capital J. So you write down this one, 9 joules, and the other is 36. Okay, so you write down this one. If the speed increased by 2 times, kinetic energy increased by 4 times. So it is good to ask yourself, what happened if kinetic energy, if the speed increased by 3 times? So the kinetic energy will increase by how many times?
6 times.
No, it's 9 times. Yeah, because it's 3 square. Okay, the reason because 2 square, right? 2 to the power of 2 is 4. Okay. So if it double, right? So if the speed triple, that's been increased by 3 times, 3 square is 9. Okay, what about 4 square? If the speed increased by 4 times, kinetic energy will increase by 16 times. It's to the power of 2. Okay, understand this one? Yeah. So that's why in real life, you know the bullet, right, fired from a police pistol is actually quite light, but can cause great damage because it's traveling at high speed. How how fast is the speed? It's about 300 meters per second. Okay, 300 meters per second. Usually the speed of a bullet. Okay, thank you. So you copy down this. This is to let you appreciate if the speed increased by 2 times, kinetic energy increased by 4 times. Okay, now if I double the mass from here, 2 kilogram to 4 kilogram, right? 2 to 4 is double, right? You do the investigation, put in the formula. You will notice that if I double the weight, the kinetic energy only doubles. So from here, we can draw a conclusion. Speed will affect kinetic energy more than the mass. Because speed you double, right? Kinetic energy increase 4 times. But weight you double, you will still double. Yeah. So this is two effects of kinetic energy, how it causes it to increase. I'll pause for a while for any question. Okay, next, you need to learn about application of kinetic energy. Where are kinetic energy in action? So in our everyday life, you move your hand, this kinetic energy. Any moving object, as I speak also, my mouth showing kinetic energy and sound energy. Okay, dams is in those countries where you got big rivers and high mountains, right? They dam up the river to direct the running water to turbines. As a turbine spin, the kinetic energy of turbine is changed to the kinetic energy of the magnets inside. As a magnet spin, they produce free electricity. Oh, free electricity. So this is hydroelectric power. And then in Singapore, if you go to the seaside, right? In Changi Beach, there are some sailboat. You know the sailboat, right? They have this sail, right? Right. So as the wind blows, right? The kinetic energy of the wind causes the sailboat to move. Okay. So if it catches the wind here, the sailboat will move here, this direction. Windmills, you know, right? In some countries, in Denmark, they got a lot of windmill. Yeah, they use not wind energy, it's actually kinetic energy of the wind. Or we say kinetic energy of wind to, as a windmill turns, right, they may use to grind certain thing inside. So next, potential energy, 3 types. You learn gravitational potential, GPE, chemical potential, and elastic. Most frequently tested is this one, GPE. Okay, GPE also got a formula. The greater the height, you fill in this blank, right? The greater the GPE. Okay, so GPE, you see that this person dropped this rock, right? So as you hold this rock at the maximum height here, it's all potential energy. As the rock comes down, right? Halfway, halfway means you have half PE and half KE. because the rock is moving down. So when the rock hits the ground, there's no PE already. You can see it become all KE. So can you add in this statement here, which I written here? At impact, right? At impact, all GPE converted to KE plus some sound energy and heat energy. Sound energy is because boom, the sound. Heat energy because at the heat, right, there's a friction. Some heat is produced. Okay. GPE means gravitational potential energy. Okay, this energy is possessed by any object that is above the ground. So later you'll learn there are three factors that affect. The next page is this formula. Mass times gravity times height. Similarly, this thing is not tested in PSLE, not required in PSLE, but it's good to know, especially if you're taking part in the Science Olympiad. Anyone taking part in Science Olympiad, they will test you this. No, but never mind. Good to know. Okay, for the Earth, right? You know, all of us live on Earth, right? So Earth, this G we take as 10. Okay, do you know that if you go to the moon, right? The closest moon to the Earth, right? You know, moon, sometimes you can see the moon at night, right? Yeah, moon is a satellite. If you go to moon, the moon's gravity is 1/6 of the Earth. So if you weigh 60 kilogram here, you take the weighing machine, you stand on the moon, you will weigh 10. Because the gravity of the moon is 1/6 of the Earth. Okay. Yeah, so the Earth will use 10. That's why it's, let's say your mass is 40, right? 40. Okay. There were 40 times 10. Let's say you're 2 meters above the ground, you times 20, times 2. So this example, we can calculate these two balls again, ball A and ball B, right? Same weight, 2 kilo, same mass, 2 and 2. But both drop at different height. Ball A is 5 meters, ball B is 10 meters. So you notice this double, right? So if the height is double, the GPE doubles. Yeah. So because G is fixed, G is 10. Mass also fixed, mass is the same. So you need to change the height. So on the left, you can see there's 100 joules, and on the right, 200 joules. So you write in the final statement, the conclusion. Write down already. Okay, if the height doubles, the GPE increase 2 times. Okay, now another example. Keep the height the same, 10 meters, but now change the 2 kilogram to 4 kilogram. You also discover that if the mass double, right? If the mass double, the GPE also double. Okay, so I'm comparing this 400 with the 200. Can you see this part? Because I'm using a 2 kilogram, right? This is 4. So from 2 kilogram to 4 kilogram, doubles, right? Height remain the same, 10 meters, 10 meters. Clear? You heard of a high-rise littering? People throw heavy object from HDB flat and hit somebody. This is the reason, because at a great height, the GPE is very high. Yeah. They'll reach a very high speed. You hit somebody, it can cause serious injury or death. This is called a high-rise littering. So in certain places in Singapore, they got such reported incident I ever see before. They install camera. The camera faces the top. They want to detect who are the people who throw things from the high floor. No, the camera can detect motion, like people throw things. Because, yeah. Okay, next. Let me finish this one first. Okay, maybe I pause for a while. Okay, from here, elastic potential energy, right, is anything that can stretch or compress. Okay, so like rubber band, you can stretch, right? And then when you step on the weighing machine, the spring is being compressed. Every night you sleep on your mattress, right, the spring inside is being compressed. If your mattress has this sort of spring, of course, this is a small spring. Okay, spring compression. So this one stores elastic potential energy. Okay. So you know this example, in the past, people like the soldiers, they don't have guns, right? They use arrow. So if you can pull the arrow, this string, right, very tight, and release it, the elastic potential energy stored in the bow, right, in the string can convert to great kinetic energy as it fires out. Okay. Next is this one. So this one you don't need to worry too much about this formula because you will learn in secondary 2 and 3. Okay. Okay, this one you need to know because this is your favorite food. All the food that we eat, right? And the fuel for the car stores chemical potential energy. So this one, you can write your own thing because your worksheet is blank, right? Okay, you can write your favorite food down here. Sources of chemical potential energy. So for example, if you like hamburger, you write hamburger. No, I just give example because all food sources are chemical potential energy. And next one, the fuel means used for burning or used for the cars to power, right? Kerosene, petrol, all these. Solid fuel and charcoal. You know charcoal, right? The black thing that they use to roast satay, right? Also contains chemical potential energy. Okay, there's one application question here. How does the sun convert sun energy, right, or light energy convert to electrical energy? Because there is this solar panel. Yeah, there's no heat energy. I don't want the heat unless it's a water heater. Heat energy, no. This one is solar energy converted to electricity. Nowadays, there are a lot of houses in Singapore. They make use of solar panel because Singapore has sunlight every day for at least 10 hours. So free energy for 10 hours. Yeah, tropical countries. Yeah. Okay, then this one is a bumper car. Describe the energy conversion in this situation. So this is what have happened. If you step on the pedal, right, they form a closed circuit. The electricity from the power source will go to the ceiling and they come down here and then they form a closed circuit. So this is the old type of bumper car. Okay, this one is there's constant electrical supply on top here, and the floor is a metal floor. The metal acts as a conductor. But nowadays, for safety reason, right, they don't use this. They use a rechargeable battery. That's when they put the power, right, the battery inside each bumper car. So they do not need to have this ceiling here. They do not have this thing here. So this is a first generation type of bumper car. But there are pros and cons. Okay, the pro for this one, the good things for this, because you don't have to worry that there's no electricity. As long as there's power supply, all the bumper car can move. But however, if you use the modern version, the safety one, once the power drain, they need to stop the services for maybe 3 hours to let the battery recharge. Okay, if you've gone for any cruise in Singapore, right, Star Cruise, right, they got that type of bumper car. Okay, they charge the power inside like power bank in each bumper car. Yeah.
And yeah, ask box another bumper car will the kinetic energy be transferred.
Definitely. So if you ever see a bumper car, if they hit each other, right, the kinetic energy is converted to another type of energy, also kinetic. Yeah, kinetic to kinetic, the person will rock. So can you copy down this answer? This is a description of how energy is being converted in this situation. So I will pause this and ask any question later. So to summarize what I have learned today, you've turned to the first page, right? About this concept, energy cannot be created or destroyed. And then what affect kinetic energy is determined by the mass and speed. Speed affect more than mass. When speed double, kinetic energy increase 4 times. When mass double, kinetic energy increase 2 times. And then this is example to prove that. And also different type of kinetic energy in daily lives. Okay, potential energy, there are 3 types: chemical, gravitational, and elastic. Okay, so gravitation is affected by height and mass. Okay, height and mass. And then, yeah, this is a proof here. Elastic potential energy, do not worry too much. You just need to know the longer the spring being stretched or compressed, the more elastic potential energy is stored. Okay. And then the chemical potential energy is found in all food and fuel. And then example of how energy is being converted. This is a good example. You can free screen and take note of this commonly tested question. And those of you who want to revise, you can go and visit my One Academy Science YouTube channel to revise what I have learned today. And I wish you all the best in your learning with One Academy. Thank you very much. Take care.